Hoy en Toquin Tech, Diego Slezak se junta con Oussama Khatib, el director del Laboratorio de Robótica de Stanford, para conversar sobre el futuro de la robótica.
Hello, Oussama. It's a great pleasure to have you here in Argentina. And let's start from the beginning. You work on autonomous systems, autonomous robotics. How do you define autonomous and how do you define a robot?
Robotics actually is very simply defined. It is the idea that if we are looking at the world, we have sensors. So these sensors are collecting data and a lot of signals, but unless we make sense of those signals, we cannot perceive what is in the world around us. And what we are doing in the world, we are acting. So robotics is simply the intelligent connection between perception and action.
And in that definition, I would say that maybe a kitchen or a washing machine is a robot. So what kind of robots are you interested in and which are their main characteristics?
So if we take a simple manufacturing system, automated system, they have feedback. They have some sensory feedback at some level of processing, but this feedback is not really the perception of the world. What we are talking about is a robot that is perceiving, recognizing objects and obstacles and different aspects of the environment where it is operating, and it's making intelligent decisions. Now, this is where there is the difference. If that decision is already made by automation, then the smart machines can be included. I think really the challenge is you have to imagine a robot in an environment that is not well known. You are going to recognize the environment and understand what is in it and connect all of that understanding to what you are supposed to do. So a robot is a little bit more intelligent.
Okay, than a washing machine maybe.
Right.
And you talked about the intelligence, and that word, that definition is really difficult. So from the beginnings of computer science, researchers talked about if a computer could think or not, the famous Alan Turing test. How do you apply these ideas of making a computer to understand the world and being intelligent, having consciousness in the world of robotics?
So in robotics, we are really dealing with the real world environment and real world task. And in the sense that we have a physical world, we need to interact with that world. In the digital world, so you have digital processing, and we can talk about computer doing digital processing. Robots are going to do physical processing. And that means we really need to understand how we interact with the world, how we can touch an object. You know, just for a robot to touch an object is so difficult. Humans do it without any problem, but for a robot it's very, very hard. Because when you think about robot moving, you think about trajectories. And you're going to reach a position in space, you say, this is my goal, so I move like this and I reach that position. Well, now, if you have a contact and you're going to reach that contact, if you make a small error, tiny error, you're going to smash that object. So humans have a lot of sensing. They have tactile sense. They move. In fact, the humans do not rely on precision. Like in machines, in manufacturing, we rely to go to a specific point. Humans rely on feeling their way to the goal. And that is what we're trying to do with the robots. That is how to create that physical interaction, understand the contact topology, understand the physical properties, and being able to interact with the world. Now, you might have a computer playing chess. Well, I don't know, we can characterize it by intelligent, but then that computer is not going to be able to touch a surface. So there is, I mean, intelligence is not really what characterizes robotics in the sense of the cognitive intelligence. We characterize robotic capabilities by the functional ability of the robot to perform physical interaction with the world, to cooperate among themselves, to interact with the human safely, and to do all these other things.
Robotics had a lot of change in the last years. So it started in the lab, you did all the robotics in the lab, and suddenly you went to the human world. You can see, for example, robots in shopping centers or virtual assistants in the offices and this kind of situations where nowadays you see more and more robots interacting with humans. And this raises a huge issue that's things about security and safeness. So how is robotic working on being safe to humans?
Yeah, I mean, you're putting it very well, because robots in the 80s were confined to production, where the robots was part of a process of manufacturing. And the robots was placed actually in cages, because these robots were big and precise and fast, and they were not supposed to interact with the human when the robots, the power is on the human, are very, very powerful. Now, robots escaped the cage, and robots are in the real world of human, and that means we really need to think about robots differently, because we need robots that can interact safely with human, and that has a lot of implications, not only in the software, in the algorithms, but also in the hardware itself. We need to build robots that are lightweight. We need to build robots that are sensitive, compliant, all these characteristics that makes the robot to the way human interact with the physical world, so that a human interacting with a robot will not be subject to the danger of collision that a machine can make.
In the last years, going to these unpredictable environments, in the past, you had to program things from before you started working in the robot in the real environment. Nowadays, you have very good connections. You have the cognitive services, the democracy of AI everywhere. And so how do robots interact with the cloud computing, where you can, for example, send translation of audio to the cloud and then receive back this information and act taking into account what happens in the moving environment? How is this world going in this interconnected world, or this real-time processing is doing autonomously without connection?
So again, interacting with the physical world for robots requires co-located sensing, co-located control, and actuators. So there is a lot of local autonomy that is on the robot itself when the robot is in that field. However, much of the higher level, the knowledge, all the things that the robot might need, the robot can get it from the cloud. And the idea is a robot in the future is not just a unit. The robot is going to be part of a team of machines that are interacting, and those different machines form this environment where you have a collaborative number of systems working together in a world that is also a smart world. So we talk about ambient intelligence, that is an environment equipped with sensors that is communicating with different robots. So a robot would know the position of the other robot. A robot would know what has been achieved by the other robot and what kind of interaction it is going to require. But also it's going to communicate with human and is going to be able to understand human gestures, human commands, and be able to interact both with human and cooperate and collaborate with other machines in an environment that is equipped with a lot of sensors, and in addition to the ability to communicate with the cloud and get input from experts. So later we maybe have the chance to discuss how we interface humans and other experts to a machine. But this is a part of the future of robotics. It's really collaborative robotics that brings inputs from different agent, from different human, all involved in a challenging task. Ocean One is aimed at bringing a new capability for underwater exploration. The intent here is to have a diver diving virtually, creating a robot that can be the physical representation of the human, a humanoid robotic diver that can have bimanual capabilities. So it has two hands, it has stereo vision, and the most amazing thing about it is that you can feel what the robot is doing while sitting up on the boat. And this is combining the technology of haptics, that is the idea that we can reflect the contact forces. It's almost like you are there. With the sense of touch, you create a new dimension of perception. La Lune is a 17th century shipwreck located about 20 miles off the coast of Toulon in France at 100 meters. In the last year, we have been working and getting our robot ready to take on that expedition. And we are going to land on the moon. More than 70% of the surface of the planet is water. We have a lot of structures, a lot of coral reefs to monitor. We need to reach down there. You can think about it as a solution where we physically extract the human from a dangerous area, but we let the human to be connected to the robot in a very intuitive and meaningful way. And then the human can provide the expertise, the cognitive abilities to the robot, and the two bring together this amazing synergy.
Before starting the interview, you were showing me a project, Ocean One, that was exactly this what you are telling, the avatar and a robot going in the deep sea, or the high mountains, in this case, the deep sea. Can you tell us about this amazing project you were telling me?
Well, you see me, I'm smiling.
Yeah.
Every time I think about Ocean One, I'm really happy because this was one of the really very exciting projects. I mean, the project didn't come out of the blue. It came from many years of development of robotics, starting with one arm, two arms, mobile manipulation, humanoid robotics, and finally we built an avatar to dive and reach places that human cannot reach. And to do that, it requires really a very sophisticated design, because we're not talking about just a vehicle that is going to swim underwater. There are fantastic vehicles today, but we wanted to build a robot that has hands, arms, and body that can substitute for the human, and that can reach. Human can dive for 40 meters, but beyond that, it is impossible. And the depth of the oceans and seas are so far deep that we have really not explored except very little from from the seas and the oceans. So Ocean One was designed to reach very deep, and we took this robot to the Mediterranean. We went to a vessel of King Louis XIV from 1664. This vessel sunk that year in 1664 and off the coast of France. And we discovered it, I think, in 1993, many centuries later. So our expedition on that vessel was incredible because we were testing our robot in 1 meter in the pool, and we took the robot directly to the Mediterranean, from the pool to the Mediterranean, and we went diving. And what was incredible is that connection, because the thing amazing about this robot is that when this robot touches the bottom of the sea, you feel it in your hands.
You feel it in your hands.
This is remotely transmitted. That is, the robot is both a robot acting, but also a sensor for the human. So we move down, we touch an object, and we are going to feel it through a device we call the haptic device. So the haptic device...
You feel it in your hands.
In the hands, yeah. And now you are pushing and maneuvering, and you are feeling what the robot is doing. And one thing we forget when we reached the seabed, we were between two cannon, and we were maneuvering to take a vase, was that when you come very close to the seabed, all the sediment come out because of your thrusters. So we lost visibility. But because of the arms, we were able to feel our way and rescue the robot, because we couldn't know which direction and how to pull the robot. But this robot has arms and hands that actually work like legs, and the robot literally walked on that vessel called La Lune.
Interesting. And when you talk about this, you look very passionate about this, and I imagine you designing robots and thinking about how would it look like, not only how it works or what can it do, but how it looks like. And I was wondering, when you were a child, how did you imagine robots? How did you imagine that making a robot? Did you even imagine about robots when you were a kid?
Yeah, actually, this is a good question. When I was in mid school, I was fascinated by time travel.
Time travel.
And by these machines that are incredibly sophisticated to make you time travel, and to come back to your planet and discover the progress, the technologies. And so I was always interested in science and technology, and I'm still passionate about it today as I was before.
On time travel.
Yeah. So I tell my students I'm still doing my PhD. I'm doing my PhD with them. And we have really a lot of excitement, because what you do in robotics, you build, you spend a lot of time, but then you see what you have done immediately, because your robot is going to perform and it's going to move, and all the time there are excitement, there are improvements that you are achieving. So it is really an exciting field. I feel lucky to be in this field.
And from the movies, which is your favorite robot?
Oh, so there is a movie some times ago was called Short Circuits. Short Circuits.
Oh yes, Short Circuit.
And my favorite robot, I found it very cute. It's called Number 5.
Number 5.
And Short Circuit Number 5 is really remarkable. I mean, a simple, very simple actually robot, but it is very cute.
And to finish the interview, if you were a kid again, let's say 10 years old, 15 years old, would you choose robotics again, or would you shift direction?
There is no hesitation. I would be lucky to be a kid again and work with the robotics that evolved to a point where we have a much better computer power, we have much better mechanisms, we have much better sensors, more integrated electronics, because now all the mechatronics technology is allowing us to have distributed computing on our mechanism. So yes, I will be doing robotics again, and I think robotics keeps you always excited about the research, the field, and also you know, my robots are going all around the world, and I'm following them.
Yeah. Thank you very much for being here in Argentina for the interview.
Thank you very much. Thank you.